This is about basicity. And then let's look at the reactions of the amines. Some of the important reactions. Yeah. Yeah, reactions. Yeah, well, before that, just a little more of about the basicity. Suppose you have, how does the benzene substituents in benzene ring affect the basicity? That also I have to discuss. I got NH2. Then NH2 and OCH3 here, an electron donating group, and an electron withdrawing group, NH2 and NO2. It's an electron withdrawing group. How will the basicity affect? So this is 1, this is 2, and this is 3. Now see, this will increase, this will donate electrons. It will come here, it will come here. Okay? So it will increase electron density of the nitrogen. Increases electron density. Increases electron density. What about this one? Here it is the reverse. It is the reverse. If you draw the, you have to draw the resonance structure. Please draw. I'll write it here. Please draw resonance structures. Writing is very, very slow. Don't forget this. If you are asked to compare the basicity, you have to draw the resonance structure and show that the electron density is reduced. So the most basic is 2 is more basic than 1. And least basic is 3. Three is the least basic. Okay, so that is how you can compare the basicity of. Now, one of the important reactions of amines, the most important reaction of amine is a very, it's a nasty reaction, in fact, which is called a carbylamine reaction. Oh, my writing is very, very slow. Carbylamine reaction. Carbylamine reaction. It is a reaction between amine C2H5 and H2, C2H5 NH2 plus chloroform CHCl3 plus potassium chloride, potassium hydroxide. You will get a nasty pungent smelling gas C2H5 NC NC ethyl isocyanide ethyl isocyanide ethyl isocyanide plus 3 potassium chloride, 3 moles of potassium chloride plus 3H2O. So this is a carbolamine reaction, and this is a very pungent smelling gas. Very, very pungent smelling gas. Pungent smell. You can use this reaction to identify primary amines. So it's a method of identifying method to detect primary amine. You cannot, the secondary amine will not react. Tertiary amine also will not react, will not give this reaction. So it's a test. It is a test. They use the word test or method. Okay. So this is the most important reaction of amines. Another important reaction of amine is conversion of amine into diazonium salts. Okay. So diazonium salts. That is also a reaction of amine. If you take an amine and react with the HNO2, normally aromatic amines. Normally aromatic amines. Now why aromatic amine? We'll just see that. See here. This is your aniline. React this with HNO2. HNO2. HNO2 is nothing but NaNO2 plus HCl plus HCl. You will get what is called a benzene diazonium chloride. N triple bond N with a positive on this nitrogen and counter ion is a chloride ion. This is called benzene diazonium chloride. Benzene diazonium chloride plus water. Okay. Now see here, this can stabilize. See this. It is possible to stabilize this compound by the contribution of electron from the benzene. But this is not possible in the case of aliphatic amines. No effective stabilization. Not stabilized. And therefore, this will be very easily decomposed. This will get, oh sorry, this will get decomposed by water into alcohol. H2O will attack this because this reaction is done in water. And nitrogen bubbles will be coming out. Plus N2 gas. But this one is quite stable at 0 degrees Celsius. Remember, this is to be done at 0 degrees Celsius. 0 to 5. Okay. So this is a preparation of benzene diazonium chloride. Now, benzene diazonium chloride is having very wide applications. Wide applications. Okay. You can convert this benzene diazonium chloride into many other compounds. What I will do is I will write in the center. That is very interesting. Let us see. Let me draw the benzene diazonium chloride here. I write only N2Cl. Okay. Let us see one by one. If you take this with H3PO2, that is called a hypophosphorus acid, H3PO2. In presence of HCl, you will get benzene. That means N2 gas has gone out. Okay. Now, if you heat this, it will react with water. You don't have to even boil it. You just have to keep it at, just slightly heat it. This will react with water and will form phenol. Look at the way you can make many organic compounds from this. You get phenol. Suppose you react this with potassium iodide. You know potassium I minus is a very good nucleophile. The I minus can attack here and remove this. And you will get iodobenzene. You will get iodobenzene. Now, in the case of, if you want to replace the chlorine, you require catalyst. Chlorine is not a very good living group. So what you have to do is you have to react this with this catalyst CuCl2, cuprous chloride, Cu2Cl2 and HCl. And HCl. And this reaction is known as Sandmeyer's reaction. Sandmeyer's reaction. And you will get chlorobenzene. Okay. Now, suppose you want to convert this into bromobenzene, you should use Cu2Br2. Cu2, Br2 and HBr. Okay. Now the same reaction you can do just by copper. Copper powder and HCl. Powder and HCl. And that reaction is known as, again you get Cl here or Br. That reaction is known as Gattermann reaction. Now you can do one more thing. You can react this with cupric cyanide and potassium cyanide. CuCN twice and potassium cyanide. You'll get the cyano compound, phenyl cyanide. Or you can use copper and potassium cyanide. That also will give you the same product. Okay. Suppose you react this with the HBF4, fluoroboric acid. What happens is, first you get the fluoroborate salt N2 plus and BF4 minus salt. This on heating will give you fluorobenzene. Look at it. Variety of organic reactions can be performed here. Variety of, okay. And you can do one more thing. If you take this salt and react with NaNO2 and copper powder, NaNO2 and copper powder. Something interesting is you get your nitrobenzene. Sorry, NO2, nitrobenzene. Right? So many reactions. There is another reaction. Oh, I don't have space now. Anyway, look here. If you react this with benzene and sodium hydroxide, these are new reactions I myself am seeing now. Benzene plus sodium hydroxide. Okay, you get benzene, one more benzene ring is attached here. See this. It is called a biphenyl. This is biphenyl. So if you are asked a question, most of the time you will get a essay. Many times you will get an essay. Synthetic applications. Synthetic applications. Synthetic applications of benzene diazonium salt or diazonium salts. What you have to do is just draw this figure, nothing else. Okay. Still more it is there. Let me write here. You can reduce this SNHCl. If you reduce this with SNHCl, you will get a new compound NHNH2. Which is called a phenylhydrazine. Phenylhydrazine. Okay. And if you do a very stronger reduction, if you do a zinc and HCl, oh, this is not SNHCl, SNCl to HCl, sorry. This is very important. SNCl to HCl. But if you do a stronger reduction using zinc and HCl, you will get aniline back, NH2. Okay, so these are the wide applications. Now what is remaining is the coupling reaction that we'll take up tomorrow. Okay, thank you.